Hello everybody, welcome to another video lesson. Today we're taking a look at Pascal's triangle. Now we've seen this before, however, because we've been looking at series and sequences, we are going to take another look at this because next lesson we're going to get into the binomial theorem in terms of our series. So let's go ahead and take a look at our Pascal's triangle and use this to write binomial expansions. First things first, just a recap of what a binomial is. It's just an expression involving the sum of two unlike terms. So an example here is a binomial to the fourth power. I've got x plus 4 all raised to the fourth power. Now our triangle is just a representation of the coefficients of this expanded binomial. So if I took this x plus 4 raised to the fourth power, I can use my triangle in order to find out the coefficients of this expanded binomial. And our triangle looks something like this. Now our first two rows are always the same. They're made up of a little triangle of ones. And again, what this is representing are these binomials here. Okay, so as each row that I go down, I'm actually going up one for my power that I'm raising this to. So a plus b to the 0, well, anything raised to the 0 power is 1, so of course that's going to be 1. And then a plus b to the 1 power, well, that's the same as just a plus b, so those coefficients are going to be 1 and 1. So this is just giving me the coefficient for each term within the expanded binomial. Now notice here the number of terms that I have. Notice that that is 1 greater than whatever my power is that we're raising this to. So here, a plus b to the first power, I have 2 terms. A plus b to the second power, I have 3 terms. Okay, and so on. So that's going to be important, especially next lesson when we get into binomial theorem. And here is what like when they are expanded out. You can see here in red, we have our triangle starting to get filled out. I've got 1, 1, 1. I've got 1, 2, 1, 1, 3, 3, 1. So these are the coefficients that we're actually talking about. Okay, so that's our recap of our Pascal's triangle. Let's take a look at 2 examples. First, we're going to look at a binomial sum, and we're going to fully expand this. So I've got 2x plus 3y, all raised to the 5th power. So again, the first 3 are pretty easy. If we memorize what this looks like, then we can just keep going from here. So the first 2 are always just 1, 1, and 1. 1, 1, and 1. And then from there, we're just taking, and then I guess our third one is going to be 1, 2, 1, because we're just taking the sum of the 2 terms above to find what this next term is going to be. Okay, that's how we build our triangle. So in order to find this 2, I add 1 and 1, and then my outer terms are always going to be 1. Okay, so the sides of my triangle are built out of these 1s. So now what we have, I will have 1, 3, 3, 1, and again we get these 3's here by adding this 1 and this 2, and then this 2 and this 1. And then our next row looks like 1, 4, 6, 4, 1. And I get that again. I add 1 and 3. That gives me this 4. 3 and 3 gives me this 6. And 3 and 1 gives me this 4. And I just keep going down. And you'll notice that whatever this second number is, the second coefficient, that is actually going to be equal to this index that we are raising this to, this power that we're raising this to. So if I'm raising this to the 5th power, then I know I need to go down to where this second term is actually 5. Okay, so that's 1, 2, 3, 4, 5, 6. It's actually the 6th row. Okay, but this 5 needs to match this 5 right here. That's how I know what row I'm using in my triangle. Okay, so using this, I know I'm going to have these coefficients here. However, since I have 2x plus 3y, it's not just x plus y, it's going to take a little bit more. So let's take a look at what these terms are going to look like. Okay, my 1 from my triangle, we get here. Okay, so that's what's going to be right there. So my 1 for my triangle is just this first one right here. And that is the coefficient that we're going to start off with. Now, my terms, 2x and 3y, we are going to start off, they always need to add, their powers always need to add to this 5 right here. Remember that. So my first term starts off with whatever my power is, 5. And my second term always starts off with a power of 0. And then when I move to my next term, the coefficient that we're going to multiply that by is going to be this 5 here. That's just this 5 from our triangle. Now my 2x, it's going to go down a power. So it's going to get raised to the 4th power. And my 3y, that power is going to go from 0 to 1. So it's going to go up a power. All right. And they always need to add to 5. So So now I'm going to have 2x to the fourth, 3y to the first power. Plus now, again, I have 10, and I get that from my triangle, 10 times 2x to the third, 3y to the second power. Again, I am subtracting 1 minus 1 in order to get this 3, and I am adding 1 to get that 2. So I'm subtracting a power from the first term, and I'm adding a power to the second term. All right, so then I can add, again, I've got a 10 here, times 2x squared. Again, 3 minus 1, that's going to be 2, so 2x squared, and then 3y. Instead of 2, I'm going to add 1 and get 3. Okay, and then moving on to our next term, we'll have 5 times 2x to the first times 3y to the fourth. And then our last term here, again, a coefficient of 1, and then I'll have 2x to the 0th power and 3y raised to the 5th power. Now from here, we need to start simplifying as much as we can. So let's see, 2x to the 5th, that's going to be 32x to the 5th. And again, I have my coefficient of 1 there. And then anything to the 0, remember, it's just 1. So this term and this term are going to be 1. And then I'll have 5 times 16x to the 4th, 3 times 3y, plus 10 times 8x to the 3rd, 9y squared. So I'm just kind of distributing through and simplifying each one of these terms here that are being raised to some power within my binomial. So then I'll add 10 4x squared times 27y to the 3rd, plus 5 times 2x times 81y to the 4th, plus 1 times 243y to the 5th. Okay, and again, my 2x raised to the 0, that just goes to 1, so I don't have to worry about that term. And then from here, again, I just need to multiply all of my coefficients together. So I'll have 32x to the 5th plus 240x to the 4th y plus 720x to the 3rd y squared plus 1080 x squared y to the 3rd plus 810 xy to the 4th plus 243 y to the 5th. And that would be my fully expanded binomial. Okay, taking a look at a binomial difference now. So I've got 2x minus 7 all raised to the 3rd. So let's start making our triangle. We're going to expand this using Pascal's triangle. So again, my first 3 rows always look the same. I've got 1, 1, and 1, and then 1, 2, 1. And I just get that 2 by adding these 2 terms above it. And then I've got 1, 3, 3, 1. And this is what we want to use, this row right here, because my second term here is equal to the index of this binomial. Okay, so whatever power I'm raising this to, when I hit that, when that second term is equal to that power, I want to stop at that row. So let's go ahead and expand this here. I'll have 1 times 2x to the 3rd times negative 7 to the 0 power. Again, these always need to, first one's going to start with whatever my power is. The second one's going to start at 0, and you're just going to start working them in the opposite direction. We're going to subtract 1 from the power on the first term and add 1 to the power on the second term. Okay, plus 3 times 2x squared times negative 7 to the 1st, plus 3 times 2x to the 1st times negative 7 squared, plus 1 times 2x to the 0 times negative 7 to the 3rd. And then we just start reducing, or we just start simplifying all of our terms here. So our powers that are to the 0, those terms will go to 1. And then I can just multiply all of my coefficients together. So my first term will be 8x to the 3rd. My second term will be minus 84x squared. Okay, keeping in mind that I have this negative 7 here, so that's going to change the sign of what we're doing. So it's going to be, instead of being plus, that'll be minus, and then we'll have plus 249x and minus 343. And that will be our final expanded binomial. Okay, so when I have a difference here, a binomial difference, keep in mind that your power or your sign is actually going to change between each term. So that's it for this video, guys. Good luck with your practice.